Okay, hello, welcome guys to our 13th lecture. Today we are going to discuss object-oriented programming in Python. And the C++ version of OOP is covered in Computer Science 200. They have a whole class talking about C++, but we only have to cover that in 2 lectures because we only talk about some basic concepts and because we are using Python, which is having simpler syntax. So let's get started. So the study goal today is the objects, what are the objects, and what are the attributes of the objects, and what are the member functions of the objects. So the next lecture we have to cover inheritance and polymorphism, and string and representation, and using F string. So this will be lecture 14. Today we only discuss the top three. Okay, so object, attribute, and member function. So class and object. Um, Object-oriented programming is very widely used in many fields, such as we daily use computer games and simulations, and also creating kind of like bank system or all kinds of systems. Yeah, because we have multi-users and multi objects involving together, and each one has their own characters and having their own skills um, and their capability to access something, maybe access data or maybe things like that. So today we will use the example of the famous classical game called Plants vs Zombies. So we just call that PVC. Yeah, I guess everyone have played it in their childhood, maybe even adulthood. Like when I was learning object-oriented programming, I just play this game every day, trying to understanding object-oriented programming. So I think this is a very good example of talking about object-oriented programming. So I use this example. So how are we going to use this example to talk about OOP? Like starting from next slide. So talking about objects, when in maybe you're not familiar with the word object, but what about using role, the word role or character? So in the game PVC, we basically only having 2 kinds of roles or 2 kinds of characters. One is the plants, one is the zombies. So in other examples other than games, like when you try to attend class, in the school, there are teachers and students. We have 2 roles there. And also in the banking system, when you have the bank authorization, and you also have the users who deposit money there and try to withdraw money. So in the banking system, we have the bank and the users. We have 2 kinds of objects. And in the game, we have kind of like, for this game, we have plants, we have zombies, although there are uh, many kinds of plants and many kinds of zombies. But basically, for the basic bottom of the foundation, like we are starting from this kind of objects. So object in OOP is like in a system you try to implement. The object is the things that you try to involve in the system and trying to let them do something that you want them to do. For example, one them has some characteristics to represent their characteristics in the code, and also try to have some behaviors to let them do so that they can maybe either like in a game, for example, like attack some people, maybe NPC in the game or something, and maybe try to, if you are banking, like try to let somebody access some data and somebody not. So this is objects. So to create an object, we first have to create a class type variable kind of a data type. So we have to use the class to create a type of object. And we use the class to construct a bunch of new instances. instance based on these types of object. Like this is very the Denmark's OOP because we usually have the keyword class. So to implement that, you have class keyword, and you also have the name of the type of object, which is usually saying in the game saying zombie or maybe plant. So we have to capitalize the first letter so that it will not confuse the computer. And also we have a column. So when we create this, it is not creating, let's say it is not creating a single object. It is creating a kind of objects. Like for example, we have a lot of birds, and each bird in the group is an individual, or maybe it is an instance. But the word bird is what we want to implement in the class, say class bird, because um, this is a kind of species in biology, or maybe a kind of that can represent a large group of something, stuff, creatures. So this is like try to make a type of the object. It is not a single object. If you want to create a single object, you have to use this class and then create an independent object. So you can realize it, like you can understand it as this is a data type, and the data type we usually call user-defined data type. It is kind of not as a data type, or maybe you can say like that, but this is a built-in character, like a built-in character and functionality in Python that you can create an object like that, and then you can just use the object from the thing you defined. Yeah. So this is class and the object. And the second thing is to talk about attributes. So what is attributes? Question. How to know plants are plants and zombies are zombies in the code? How the code represents that? Because you are not drawing something, or you are not you're not drawing something on a computer in the code, or you are not doing something, but you have to translate from English, from the rule of the game into the code, like saying, this is a plant, and how I'm going to represent, because I'm going to represent plants are plants, before plants are plants, and zombies are zombies based on their own characters. The characters different from each other. So the answer is like use attributes. Attribute meaning the property of kind of object. So different object have different attributes, have different characteristics, and having different functionalities. So in OOP, what you're trying to do is to convert by saying events a game. You have to convert the rule of the game into English. Convert the English into the code, like English or maybe another language, as long as it's kind of the game, the rule of the game, and you want to try to convert that into the code. So we're using attributes in OOP. For example, what kind of attributes we can think about when it comes to first? We can say basically plants cannot move, but zombies can move. So you can create in two classes. You can create two stuff. One is you can create one stuff is an Boolean value, a Boolean object saying that in plants can move is equal to false. So when it comes to something like to try to uh, determine if an object is a plant or zombie, and you can try like asking if this can move. So if this cannot move, obviously it's a plant, and otherwise it is a zombie. So class plant can move is false, class zombies can move is true. So this is the object of the attribute of the object. Try to convert English into the code by using the attributes that distinguish from each other. So it's a distinct object. So because in the code, everything is letters and numbers, and computer will not understand English maybe. But if you try to convert it into Python or something, and try to say, oh, I have created some attributes, and based on these attributes, I can say it is plant or zombie. So yeah, and a class data type can create a bunch of instance attributes, and each instance can have a bit different from each other. So saying that, for example, using the example of bird, like we have lots of bird, we have sparrow, we have kind of eagle, and you can can you say they are totally the same? No, like eagles fly faster than sparrow and weigh a lot more than sparrow, and this is the difference between birds. They are both birds, but they are not the same bird. Yeah. So we're introducing class attributes and instance attributes. So the difference is that the first thing is the class attribute is the basic attributes for every instance. So for example, they have sparrow and eagle, two kinds of birds, and although they're different, but their class attributes must be the same. Why? Because they are birds. The class attribute refers to the characters, preserving their characters as a bird, like saying they can fly, they can eat, yeah, they can uh, do something the other birds can do. So the basic attributes for every instance. So they can be created directly before the initial function. The initial function, we will talk about it later, which is related to instance attribute. And for each new instance created, they will obtain attributes automatically. So yeah, so when you try to implement like plants and zombies and you use class attribute. So when you try to initial that, it must be of the attributes that other plants or zombies can have to show that they are plants and zombies. Yeah. So the instance attribute is that the attributes to be assigned when creating every instance. Um, like we usually use initial function or maybe other functions, which we will talk about later. And the instance attribute is to saying, oh, we have many bird individuals in the bird group. And maybe let's say, yeah, and we have an eagle inside and have sparrow inside. And the instance attribute is to saying these two kind of birds all have they both have some slightly different attributes that distinguish them from each other. So yeah, so instance attribute is when you initialize it as a bird or something, they must be created manually. They're not saying kind of manually, but you have to initialize that. Although you may yeah, I think it's we will talk about that later. It's like when you try to create an instance, you have to input some data, and you have to input data so that I can say this is manually. Yeah, the initial data will go into the initial function and bind value to the corresponding attribute variables. Yeah, so for instance attribute, they usually have to input some data so that they can be assigned and bound into some attributes of the stuff so that each instance can be different, although they are under the same group, under the same kind of object. Yeah. So, so let's say class and instance. So this is example class attribute. Let's say we actually have can move. The can move is true. Like the class attribute that applies to all zombies. Yeah. Yeah, if there's a zombie that's still you can stationary, you can tell me. But as far as I've known, each zombie can move. So can move is true. And then can attack is also true. Like the goal is like to attack plants and go into the owner's house. So yeah, so this kind of attributes applies to all zombies. Whether some zombies can dance, some can jump, some can swim, some can fly, but that applies to all the all the zombies. And this is a basic attribute. And usually you cannot change that. If you change that, they may not be zombies anymore. Yeah. So the instance attribute, to be assigned when creating each instance, they must be created manually. The initial data, which you will type or you will write the codes when executing the program. And then you input the data, and the data will go into the initial function. And then you bind the value to the corresponding attribute variables so that you can have different instances. So let's say zombies. We usually use initial function. This is initial function. Say define and the name, we have two dash lines, underline, underscores, and then init, and then two underscores. And then you have self. The self here means zombies. Yeah, we have to use self. When you are trying to implement an OOP, inside OOP, you are not using the name zombies, you're using self, which means myself, himself, like zombie self. Yeah. So the speed, I set the initial to 0 if nothing passed into it, and also power. And septal speed is speed, septal power is power. Like this is the attribute I create. And also when I input data here, say 4, and the speed of zombie can be 4. Yeah. If I input 2, this can be, the speed will only be 2. If I put 3, this can only be 3. So from this point, by creating instance attribute, I can make each zombie different from each other. They are all zombies, but they are like different from each other. And yeah, so let's say in this code, let's say in the terminal, I type uncapitalized zombie is a single individual, and then zombie is the name. And then I have type parentheses saying I want to create an individual, which is a zombie, and what are their instance attributes is. So I pass in two by saying that we do not pass self here. Yeah, we do not pass self here. So we start from the second one, and speed is 0, but I take in 2. So this 2. So you go into it will go into this function, and corresponding place speed is 2, power is 2. So when I type be a dot speed, we have to use dot operator to access our attributes and also member functions, which we'll discuss later. So zombie dot speed. So the speed of a zombie is 2, and zombie can move. Oh, this is the class attribute. So of course it can move. Yeah. So this is instance attribute. The first one is instance, and the second one is class attribute. So okay, so class attribute, instance attribute can be modified after it's created. Yeah, but when you modify these two, you have different results. And usually, I don't suggest you modify class attribute. Yeah. So wait. So if class attribute are modified, the attributes of all the instances will all be modified. So it's like because so for class attribute applies to all the instances under this kind of object. So if you want to modify class attribute, like saying I can move, and then maybe I want some attributes, want some instance not moved, but the can move variable is the class attribute. So if you convert that from true to false, other zombies which you don't want to modify and you still want them to move can also be turned out to be you just stop them moving because you stop all the zombies from moving. Yeah. So if instance attribute are modified, the attributes is the only modified instance. Yeah. So because the instance attribute only they're only following their own instance. Yeah, like we have some zombies like speed is 2, speed is 4, and that only applies to uh the only one instance they are following to. So yeah. So if you modify one, you just modify one. You don't modify others. Yeah. So it's this instance and class. So suppose I have this one, have this function, this class attribute, this class program. So say the zombie one is zombie 22. Yeah, this is one zombie, and the other zombie, okay, zombie 2 3. So zombie one dot speed is 4. I want to change that from 2 to 4. Yeah. Notice it's an equal sign means assign. So I just reassign the speed of the zombie one. Yeah. So because speed here is instance attribute because it's under the initial function, it is not outside of the initial function. It is not, yeah. So it is instance attribute. So when you try to modify the speed of zombie one, the speed of zombie one does not be affected. So it can still be free. However, if I want to change zombie one dot can move is false, like we assign it, but can move attribute, the variable is class attribute. So when you stop zombie one from moving, you also stop zombie two from moving. That's because can move is class attribute. Class attribute is applies to all instances of under that kind of object. It's not only a single object. It's not only a single instance or individual. But for instance attribute, you change that, you only change one individual. Yeah. So this is the difference of class and instance attribute. So next one, member function. So objects can also have behaviors. Like for example, zombies can eat plants, plants can attack zombies. Like in real life, you want to implement cat, cat can run, can eat, can also climb trees. So if you want to modify, if you want to write something about the object, you may try to mention its behaviors. And in Python, we use member functions. We in OP we use member functions to represent the behaviors of the object in the code. Yeah. So to try to allow the object to do something, kind of. Yeah. And so the member functions can be considered as also as an attribute of function. So, but in a function type, like the things we are talking about are only Boolean values, integers and something. We have speed integer and can move Boolean value. But for member function, you can consider it as an attribute, okay. And in the function type, because a behavior of a person can be an attribute, like, yeah, like if like saying someone can drive a car and this can be an attribute of him. Yeah, like a property saying that oh he can do something, so it's different from someone who don't drive. So okay, so the construct initial function is also a member function. We have introduced the one special member function, and which is usually use initial function because you have to create instance attribute. Yeah. So next one. So for example, when a zombie attacks a plant, every time the zombie attacks a plant, the plant's health is reduced by the power of the zombie. So for here, we try to let the zombie attack the plant, kind of. Yeah. So we have a lot of stuff we mentioned. Yeah. So we only see the highlighted words, like so this is the attack function. The member function attack we have already have it is new added into the zombie, and the starter bub is we have already implemented. And the attack, okay, seems like a while loop inside. So I have a bunch of questions. So what is the self here in the attack? So the self here is attack self plant types. Okay, the self. Let's see what OOP class what what kind of object we are trying to implement in this OOP. So we see, oh, it's class zombies. So the self is zombies. Like the self is referring to zombie itself. We are implementing zombie. So inside of his, yeah, he will refer himself as a self. Okay. So the self here will be the zombies. And what does the attack function pass in? So it passes in self. It's important, like we are trying to say, oh, zombie. So means refers to zombie, and the plan is a plan object the zombie is trying to attack. Um, so the times. So let's say how many times the zombie attack the plan, and yeah, so you may attack the plan once, twice, maybe 3 times, 4 times, etc. until the plan is dead, or yeah, until the zombie is dead, maybe. Yeah. So what can the self do to the plant in the tag function? How's that represent code? Uh, which is saying actually it's saying how zombies attack plants. So we can back to the English description here. So for example, when he attacks a plant, every time zombie attacks the plant, plant's health is reduced by the power of the zombie. So I already have the power, self power is power. So every time, so means we have to count down like how many times each time what we have to do. So each time the plant's health must be reduced. By how many? The power of the zombie depends on maybe it's one of 2 or 4, depends on the individual zombies. So okay, so back in here. So we have while loop. So um, so it's saying every time the text, this is the attack process. So when can the be attack? When the times is positive integer, like is greater than 0, means oh I have 3 times left to attack the plan, maybe 1 time left, and the plan's health is oh if the plan is dead, let's say the health is 0 or less than 0. So I don't have to attack that because it's dead. And yeah, so and then during this, we say plant health is reduced by the power. Always self here. Self is the superior. Yeah, self is superior. So self the power depends on the power we take into, and which time is reduced by 1, and times minus equal 1 reduce the times by 1 because we're showing that method narrow down the counter, showing that oh I've attacked it once, so I reduce it by once. And then I back to the while loop to evaluate again. So for example, I have Symbian object, Symbian 2. And let's say there's a plan, maybe assume that we have created using the plan object, the plan OP. So plan of health, I assigned it to 4. So yes, the health 4. And power of zombie is 2. So the zombie only have to attack the plant twice to make the plant dead. So of 10, we don't take in attack though. Sorry, we don't take in zombie though. We don't take in self though. Yeah. But it's a zombie dot attack. Zombie is the object who do this behavior. So zombie attack plant 2. So yeah. Plant health. When you attack them 2 times, like twice, the plant will dead though. Like because they have health and they attack the plant once, and each time the health is reduced by 2 because 2 is the power of the sphere. So plant health will be 0. So which means the plant is dead, kind of. Yeah. So this is how attack function is doing. Like when you do attack, you have to process the attack individual. You only have to like change some data to uh, to satisfy with the English description. As I just said, OOP is to translate the rule of the game into the code, translate English into code. Like I guess it's simpler than things like GCD or something, but yeah, it's a very kind of understandable concept. Like usually you invent again. You want to convert the words in English into words in Python. So this is how we translate the process by saying, oh, the results like the plant's health is reduced by power. So we do this. And also we have to count down every time how many times the attack. When the times is over and we have to stop attacking. Yeah. So okay. So use stock product. We have a lot of stock product there. So yeah. So the top product is like try to saying health of plant attacked by zombie, health of plant, saying that a kind of relationship like who assign like the plant, uh, whose property is that, or saying like for example the property of plants, and or maybe saying who assigned the behavior, like saying zombie assigned the behavior attacked towards plants, twice, yeah, twice. So use stock operator to show the relationship by try to say um, which property is that, or maybe who assigned the attack, who assigned the behavior. Yeah. So this is member function. Okay. So in the practice here, this is the two linear data structure talking about stack and queue. Yeah, this is the first lesson of data structure. We can implement it in OOP because it's often and it's usually don't quite difficult to understand. We don't actually go the stuff like this very far, very deep into it. But using OOP to create them is fun. So let's say making a stack with OOP. So the attribute of a stack is to first check if it's empty. Like we'll be using a list kind of um, saying 1, 2, 3. Can list use a list inside, try to make the list. I think, yeah. So check if that's empty, and check for the size. How many elements are there? And check for the front, check for the back. And the member function is like to push the element inside and pop it out. So instead we say LIFO, which means the last in, first off, first out, saying the last one coming to that stack will be popped out first, will be removed first in the data structure. So uh, this is diagram of the stack. So when you push into it, and then you are going to be the first to pop out. Yeah. So this is stack. And queue is like the same here, but we have in queue and DQ. In queue is like you join the queue from the back, but DQ is like when something comes to you when you are like waiting in line and you're the first one, you go first and then you just leave the queue. So in queue is to um, make the data join the data structure from the back and pop out the data from the front. So this is queue. Okay, and we are going to use a container kind of. We are going to use a list as a container, but we are trying to control the list to make it like to correspond to the property of stack and queue. So let's do it. So uh, so the first thing we have to do is say stack. Right? So we don't have class attribute here though, but we can still do first with initial function. I think, yeah. So like every time you write OOP, usually you have to use initial. Um, so it's like self list. You pass into list, then you say self dot with is list. To convert that in to convert the passed in data passed in variable into your own property, into your own attribute. So we have to use self-list. We are not going to use the list directly because self-list is like uh, it's like making this attribute bind to the self so that it can travel through so many member functions. If you're using a list, only this list, it can be only accessed in this function, initial function, which is not we're going to expand. So just we have the attribute list in the self, and we bind the passing list to the attribute of the self, to the attribute list of the self, so that the self can be accessed and can travel through all the member functions in the stack. So this is why we use self, why we use initial function. Yeah. So because in stack you also have the problem of frame, scope, things like that. Yeah. Environment. So the next one is check for is empty. So I would just say is empty. So we have self. The self is containing the attribute list here, so it can be passed into it. And then I think that's it. So return return to say if it's empty. How to say if it's empty? Yeah. You just say self dot list equals an empty list. I think that will work. Like it return true or false. So next one. Define a size self. Oh, that's easy. Just return the length. Oh, you can also do. I think that would be better. So, oh, this is selfless. So return length of self dot this equals 0. So I call this. I think this also works out. But you make a bit weird. So I think okay. So defined font. Check for font. Okay. Let's say font self. So you return self dot with the first one, which is 0. So also back define back return uh um, the last one -1. Oh, these are all member functions. Yeah. So they are not just simply attributes, I guess. So I'm making mistakes here. So they are all member functions. So, but they are not behaviors. They are only show the property of the stack. They are only to show the property. But for the thing below there, I will do some behaviors. I will do some behaviors saying like initialize something, maybe put something into a list. So I will do something. Like for here, I just return. I just have the property. Yeah. So push out. But you have element, push element. So uh so say out of list. Uh you can have a pen with better. Yeah. Or you have other options saying self list dot extend. Make a list. Yeah. Or maybe you say self dot list plus equals the element. I think they also works out. Yeah. So the last one, pop. That would be the same as the behavior when doing the list pop. So we input nothing. So we can try it out. So I can also talk about why in this we also use star operator. You can actually think of a list as a built-in class data type. So uh, they also have a lot of things like append, extend, and pop, also insert something. You can consider it as a member function inside the class list. I think so. Yeah. So you can try running it to check. So say a stack equals to capital stack. So um, let's say just type in with this, say 1, 2, 3. Okay, so I'm creating an instance of a stack. So to check is if that's empty, I think the answer will be false. I say like, although we only take in self, this is a function. So we have to use parentheses because it only takes in self, but we are having stack dot is empty there though. So it's false. And we also have another type of implementation saying we use the class name stack. Oh, stack dot is empty. But this time we have to include self. What is the self? Stack, but uncapitalized one. Stack, then nothing, only typing this. So also return false. These two are equivalent. You can use either of them, but it's better you use stack. The stack dot is empty, nothing. Yeah. So what about the size? Oh, size will be 3. Yeah, and also front front will be 1, and back will be 3. Yeah, and push. Okay, push is important. Let's say we push 5. So we have to say if there's actually adding 5 at the end. Oh, when stuck. I guess we have to print stack. Oh, I have to use show the show function showing that what's inside there. Yeah. So return self-list. We will discuss about string and representation for the next lecture, and this is actually included in the lecture, but I'm not going to use that now. I'm just use a member function, another member function to talk about what's inside in the self. So yeah, I would say stack 2, 3 and stack dot push 5 and stack dot show. Yeah, it's 1, 2, 3, 5. And what about also push 10? Yeah, and show it. Yeah, it's 10. 1, 2, 3, 5, 10. And then the next one is using pop. So show stack, it'll be 1, 2, 3, 5. It just remove the last one. So that actually fits in the definition of the stack here. So okay, so now I will try to implement queue. Yeah, always capitalize your object name. Yeah. So okay, so define it self and this. So self is this, and then define is empty. Self dot just return. This time we use this one. Yeah, self dot is empty. Then define size. You will find out that it's actually very similar than the stack. So for next lecture, we also talk about inheritance, which we can inherit some kind of the stuff. Yeah, like we can inherit the attribute from the stack, so that we don't have to implement that much. So check for size, return len of the self. Yeah, all this. Find funds. So return the first one. This is 0. Define back. So self.this and define the back and EQ. Yeah. This one is different from stack. So what will we do in queue? Oh, it's just the same as you pushed an item into the stack. We call this FIFO, first in, first out in queue. So still do something like that. Self notice dot pants. Oh, for all this, I forgot to include self. And then element. Okay, how about DQ? So DQ is we don't have to pass things into it, but we have to remove the first one. So how are I going to do that? So remember we have the first principle. We have the columns. Say self dot is like we have three principle, start, stop, step. So from this point, I just don't want the first element. So I will start from 1. And I can try to initialize the first. I can try to initialize the first element though. Yeah. Yeah. I'll try to start from the second element. So I will try to start from, like in the index you say start from 1. So I would say self dot list equals self dot this 1, start from 1. Like initialize the self dot list again. That will work. But I actually want to have return self. Oh, I want to store the first element that popped out. Yeah, so it may be well equals self dot this and this one is before this new initialization, so it will be okay. Or maybe it's better to use, I think, because I'm actually breaking the abstraction barrier here, so I will instead use self.funds. Yeah. Although you are using a list to represent and store the data. I've seen so many people in computer science 200, they break data abstraction every times, although it's okay. And the teacher actually don't ban you and don't buy them. But I suggest you not to do that because yeah, because you may have that kind of concept. You may have that to remember that, like, although it's okay because we actually in the oh my God, this is class. Yeah, you're actually in the class, so I think that will be okay. But outside of this class, you have to use the attributes provided here and also the member function. They are the tools to access the everything inside this object. So yeah. So the last thing is to show. Just copy paste. Yeah. So try. Uh, you just type in. Oh, I think that's enough. Uh, we start from InQ and DQ. Yeah. So Q, we can take in 10. So Q dot show. Yeah, 1, 2, 3, 4, 10. And also Q dot DQ. I guess it return 1 though, because I say return 1. So yeah. And you want to show it again. Okay, you don't, the one disappeared and you have 2, 3, 4, 10. Yeah. So we also do a little introduction of stack and queue here. Like, to be honest, it's not difficult for these two linear data structure and um, easy to understand and nothing to worry about, nothing difficult. So I was going to have a lecture there of that, but I don't think that's necessary. And but yeah, we can talk about OOP while talking about this at the same time. We can do this at the same time, and they are actually a very good example of making doing with OOP, making OOP objects. So yeah, next lecture we will to talk about inheritance and polymorphism, and also the string representation. Uh, because as you see, when you print the object, you say, oh, it's an object, class, type, things like that. So, but I want to see something inside. So at this time, you have to implement so that you can return something that you like to see, you like to have. And also, yeah, and also inheritance, because you've seen in the stack and queue, we have two OOPs. They are very, very similar. Um, many of them, many member functions and attributes of them are actually overlapping. So we can just implement a staff that combines two characteristics, and then we can create a new class by, and also inherit uh, all the characters and attributes from the parents class, so that you can have combined attributes, which we will talk about in next lecture though. So thanks for watching this, and guys have a great weekend.